All right, hello. All right, sweet. All right, hello. Everyone hear me again? Yep. All right, sweet. So the email for the week got sent out. Really quickly, I want to let you know, in the attendance is a question about what you want to see demoed. Today, there really is not a lot for me to talk about. I'm going to talk a little bit about 3D printing. It is the second half of our class. So a little bit about 3D printing. I'll tell you about, slicing. So slicing is the process of converting your file from Fusion to a 3D printer to get it to print. So I'll talk about that for a little bit. A big part of your project is going to be rendering. So it's a little more of like a photography style assignment. Talk a little bit about that, but it should maybe be no more than 45 minutes. So if there's something that's really kind of bothering you or you're really curious to learn, you can drop it in that attendance link, and then as soon as I'm done lecturing, I'm going to open up those submissions, and if any of them stand out or if there's a good amount of like repetition, we're going to go over and cover those again for you guys. So today's class, like I said, is about 3D printing, and then the last maybe 60% of the class, you guys are going to be starting on your final projects. Okay, so exactly what is 3D printing? 3D printing is a subgenre of something called rapid manufacturing, right? This is something that's kind of become new with this turn of the century, right? All about optimization, right? We want to make things better, we want to make things faster. And 3D printing is all about that faster part, right? It lets you make pretty abstract shapes, really with no limitation, and with a pretty reasonable time limit. So this little blurb right here says, the use of a computer-aided design-based automated and additive manufacturing process to construct parts that are used directly as finished products or components, right? So it allows you to, 3D printing gives you total domain over anything you design. You can pull stuff from a CAD file, and within seconds, it allows you to manufacture, right? Without 3D printing, you have to do something called drawings. It's a big part of Fusion. We're not going to cover it in this class. It is really cool, though. I think we have some other classes here that might go a little bit more into it. But other ways of manufacturing, right? So if you're going to take a part that you made to a machine shop, you can't just give them a CAD file because they're not going to take it. You need a working drawing. So that takes a lot of time because you have to get the layout correctly. You have to get callouts. So you have to tell everything, tell what every dimension is, and just like that. And 3D printing really just cuts it in half because you can just download the file, convert it over to a different type, and within minutes you have a print starting. So there's a few different types of 3D printing. The one that you're probably most familiar with is this one called fused deposition modeling. So that is the standard 3D printer, right? So the desktop ones that you can buy for fun or educationally, right? That's the most basic generic version that uses typically heated plastic to make your parts. Another cool type that's up here on the slides is something called stereolithography. That is the same premise, but works with a totally separate technology. The way that works is you will put a printing bed into a vat of a liquid, and you use lasers to heat up the liquid at specific points, and you can kind of look how it makes this like crystallized shape. So you're using a laser to kind of crystallize the material at certain points, and you can print it using that way. It's kind of the opposite of FDM, right? You're printing from nothing. You're picking out certain points and you're making it there. While FDM, you're actually laying down the material, so you're only putting down exactly what you want. So applications of 3D printing, the reason this is really important is because it's becoming really innovative in the industry. Not too sure how many of you are MEs or just engineers in general, but the cool thing about 3D printing is that it's kind of involved in just about every major field of engineering. You have stuff such as like food science and nutrition, and then you have stuff such as biomedical. It's in civil engineering, industrial, mechanical. So there's so many cool things that you can do with it because we're starting to revolutionize the technology. You can 3D print food now. You can 3D print body parts now. You can 3D print clothes, jewelry, art, and then, of course, your generic standard part, which is what we're going to be doing with this project, right? You guys are going to be designing something, and we're going to be printing out your part, just for you to have as a nice keepsake. So, again, fused deposit modeling. That is the generic standard type of 3D printing. That is what we're going to be working with in this class. So this right here like I said, the most common form of 3D printing. This right here is a Dremel 3D printer. Lots of high schools will typically use this because it's a very cost-friendly and strong 3D printer. My high school had these, for example. They worked great. Didn't really bug out too much. A little bit on the higher end, a little bit above average. Great printers though. I think this is actually what the Milestones department uses. So this is a pretty good, standard printer you see, kind of like a Toyota. It's pretty reliable. Lots of people are going to use a model like this one. Okay, so the basics of FDM, right? So how it works is you are creating something 3D, correct? But you are printing in almost a two-dimensional way, right? You are heating up filament, right? Filament is just a very thin wire of plastic, right? Generically plastic, most 3D printers will print in plastic. It's kind of wound up in a spool, kind of like the thread that you see on like a weed whacker, right? It's just very thin filament, wound up on a spool, and it gets fed into a nozzle, and the nozzle heats up to really, really, really high temperatures, and it begins to extrude out that material, right? Now, material has a thickness of typically millimeters. Now, if you want to make a part that is inches tall, right, you're going to work virtually in planes, right? So you're going to start off on plane 1, and you're going to lay down a single layer. And that's all you can do in that plane, right? Because you can't really go up. Well, you can, but when you go up, you basically change your whole level, right? So you lay down one layer at a time, and then you move up to layer 2, and then you lay down material on top of said layer, and then you just keep building yourself up from the ground. Here's a video right here that I just want to show. I think it explains it pretty well. If you know generically how 3D printers work,
what is 3D printing?
Nothing new to you, but if you know nothing at all, this is a good introduction.
What is 3D printing? 3D printing refers to a variety of processes in which two-dimensional layers of material are deposited and joined, one upon the next, to form three-dimensional objects. This process is also known as additive manufacturing, and is a fundamentally different way of producing parts compared to traditional, subtractive, or formative manufacturing technologies. How does a 3D printer work? The 3D printing process always begins with a digital 3D model that is converted into an STL file. This model is then ASME printers melt plastic filaments, and the process always begins with a digital 3D model that is converted into an STL file. This model is then sliced by the 3D printer's software into thin, two-dimensional layers and turned into a set of instructions, known as a G-code, for the 3D printer to execute. From here, the way a 3D printer works varies by process. For example, desktop FDM printers melt plastic filaments and lay them down onto the print platform through a nozzle. Large industrial SLS 3D printers use a laser to melt thin layers of metal or plastic powders. Plastics are by far the most common, but metals can also be 3D printed. Depending on the size of the part and type of 3D printer, a 3D print usually takes about 4 to 18 hours to complete. However, 3D printed parts often require some post-processing to achieve the desired level of surface finish.
Okay, I'm not too sure if you could hear any of that. We tested it before we came in, and it seemed to have been a little bit loud enough. But if you just saw what the video was showing you, right, they mentioned kind of briefly that there are multiple ways.
Let's change it up.
There are multiple ways to 3D print, but they all generally follow the same way, which is just laying down layer by layer. Because you can only go layer at a time, so you lay down your first one and then you keep moving upwards. But generically, like I said, they all follow that same path. So, okay. So to 3D print, you need some way to convert your file from Fusion into that 3D printer, right? You're gonna spend hours modeling your part, and you need some way to compress all that data into some format so that the 3D printer can handle it and can kind of compute the code for the printer to go and lay down the files. So that's where a kind of a processor comes in. There's lots of softwares that you can use. Some CAD programs typically have their own built-in one or affiliate. Fusion's a little bit more open, so there are lots of, you're not really constrained to use one, but you can download your file from your CAD software into a more generic format called an STL file, so .stl stands for stereolithography, and that file is kind of a universal input for any slicer, right? So you can take your file out of Fusion, right? Fusion only handles Fusion files, you can export it as an STL file, and that STL file then allows that whole CAD model to be compatible with just about any slicer, right? So it converts it, and you can put that file into a slicer, and then within that slicer, you can scale your part, move it around, you can choose how it's gonna print, you can mess around with supports and whatnot. And for this class, we're gonna be using the one on the bottom. It's called Cura. It's attached in the email. If you guys wanna start downloading it now, I'm gonna be doing a quick demo. We're gonna be the ones actually printing it for you, but we do want to just show you just pretty quickly how Cura does work. So there is a download link there. You guys can just kind of download it while I keep talking. It's not that big, but like I said, we'll do a quick demo about it. And then if you guys are having issues with it, you can just call us over and we can help you set it up. So again, here's just an example of what Cura looks like. This is the one we're gonna be using for this class. And then you slice it, right? So typically, you want to preview what your part's going to look like when you print it, right? Many of the parts that we're going to be printing that you guys are designing are going to take 6 around to 12 hours. So just kind of throwing a part into the slicer and then just pushing print is a really bad practice because you're wasting your time and you're wasting your money. So you want to be like 110% certain that when you print it, everything's going to go well according to plan. So one of the assignments is going to be you submitting a screenshot of the post-sliced image, right? So this would be the final step before you push print, right? You've moved the part into the printer, you've scaled it around a little bit, you've rotated it, you've pushed slice and preview, and then it's going to look a little bit something like this. Pretty colorful, but the colors are going to tell you just generically what's going on with the part. There's a little legend in the corner that'll tell you more. It's kind of cropped out of this image. But this right here is a preview of what one of the assignments is going to be in the upcoming slides. All right, so we're working a little bit backwards. The next assignment is going to be rendering it, right? So assuming that you've already made your part, what we want you to do is render it. Within Fusion is a built-in render feature. So this allows you to take your part, and we've messed around with it a little bit, but there's a way to add appearances to your part. So if you add appearances to your part, you can then open up your render tab, and you can take a professional style image of your part for free. So you can tell this is a train, this is the Boilermaker Express. This person imported a background image, and then they also applied a plasticky texture to it, right? Because that's probably what it's going to look like if you print it out of a white plastic. And then it's typically rather expensive, but with an education account, you get it for free. You get credits that you can put into the account, and you pay them X amount of credits, and then they give you a full high definition, high quality, you can probably even get it in a 4K if you want, image of your part. So like if you were ever going to put this on a professional presentation or maybe on your LinkedIn and you didn't want to have like a crummy screenshot of your part, this right here is what you should show. So for presentation wise, we think this is really important. It's also a really cool like subsector of CAD, and that's why we're including it in the final project. And then obviously there's the final project itself, which is making your own CAD model. So the whole, or at least the main part of the final project, right, we're going to be starting that today, is going to be designing something from scratch. We took away the limitation from the past of it being Purdue related, right? We saw a lot of creativity, and it kind of felt bad that it was hindered by this big criteria point. So we want to give total freedom to go out and make anything you want. But with that being said, all you're being required to do is use more than 3 design features. We're requiring you to get a full rendered image, and then we're also requiring you to show us that you know how to slice it. And that's the entirety of the final project. We're going to be 3D printing this for you guys. There's lots of kind of information in the email I sent out. So right here is all the criteria for the final project. If you're just looking to pass the class, you have it right here on your screen. But if you want something really cool to show off and kind of tell people what you took out of this class, you know, you can put as much effort as you want. There are people in the last session who told me they did their project in like 25 minutes, and there were some who looked like they spent a whole 24 hours on it. You know, there's no spectrum. This is the part where I really can't force you on how much effort to put into it. But, you know, if you want to take a little bit of pride in your work and really put a lot of effort into it, you know, go for it. And that's what we're all here for, is to support you. And if you have any questions, we want to help you get towards your final project. Also, here's a couple ideas. They're on the slides as usual, but typically offering way too much freedom can be a little bit scary sometimes. So if you need a little bit of guidance, here's just some things. The old one, which was Purdue related, you're more than welcome to do that. I think somebody already reached out to me about making some chess pieces. If you want to do that, that's awesome. If you wanted to make anything mechanical-wise for yourself, or maybe for actual utility, you can do that. Something related to your home, hobbies, interests, anything. We're giving you total freedom. With that being said, is there any major questions about the project? Yes?
Yeah, what was the size limit again?
Yeah, so in the email, we are restricting you to a size limit. It's a volume of 5 by 5 by 5 centimeters. So you can either design your parts in Fusion to meet that limit, right? So you design everything to be under 5 by 5 by 5. Or the cool thing about these slicers is they actually have a scale feature. So I told you guys I think the first week, somebody made a rocket, and I think they genuinely made it life size, because when I imported it, it was like 20,000 feet by it was massive. But there's a scale feature. So if you want to stress about making it the right size, you can. But if you just want to dimension it to whatever you want, you can then kind of avoid that by just scaling it in the software. So there is a size limit, but don't let it stress you out about how you design your part. Is there any other questions? Because if not, I'm just going to quickly demo some of the aspects of the final project, and then we're just going to leave the floor to you guys. Anything? All right, sweet. Okay, so the first thing I want to talk about is the render. So assuming you've already made your final project, you're going to have to render it and give us that professional style image. So in the top left of your screen, you'll notice that, you guys can just watch because you're going to need this later. This is an old file. This is someone's project from last semester. It's the Purdue Unfinished P. So over here on the top left is the design button on Fusion. If you click on it, it opens up a big drop-down menu. This opens up multiple different versions of Fusion, right? So if you want to get into generative design, which is using AI, machine learning to optimize your parts, there's a whole different sub-tab. If you open that up, your whole menu is going to change. It's a whole different side of Fusion. Same thing for render, animation, simulation, manufacturing, drawing, right? So all the big major things that you can take away are all under this button. The one that we want is render. So this is assuming you already have your part done. It's saved. Within your part file, you're going to open up the render tab. Right here, you're going to have the opportunity to change your appearance, right? It's the same thing that you do back here, where you go to bodies and then right-click appearance, right? Same thing, but it's just to give you an option over here in this side of the screen. So if you want to add appearances, which that is required for this render part, right? So for this, you need to render an image, you need to apply an appearance to the part itself, and then you need to apply a background. So with this button, you can add an appearance to the part. And then with this one, which is next to it, scene settings, you can add a background to it. So I was messing around with this before you guys came in, and there is a library of free backgrounds. So if you open up scene settings, right, this is pretty much photography, right? There's nothing really cat about this. You'll notice the words, right, brightness, there's another one, focal length, exposure, aspect ratio, right? If you're into photography, this is right down your alley, but if you're not, just mess around with it as you like, right? This is all about showcasing your part. So you can mess around with this if you want. It's not required, but over here in the environment library, there are a bunch of preset backgrounds. So we're asking that you put a background, that you put a background on this image when you go to take a screenshot of it. So you can go into settings, and then in background, you can change over to environment. And then it allows you to take images with the background. You can use any of the ones that they have, or if you go all the way to the bottom, there is a replace custom environment. So if you want to import anything from the internet, we encourage you to do so. However, I will let you know, you are restricted to a certain type of file format. I sent it out in the Slack. There is a link to this website called Polyhaven. I found it a couple minutes ago. So what you need is a high definition resolution image. And this website specializes in having them for free, right? You can't just go get a random JPEG off the internet. Fusion's not going to allow you to do it. You need to have certain types of images. So this is a free resource that I found that you guys can use. So if you go to assets, HDRIs, all of these are high quality render images. So if you really want to get fancy with it, you can go and find some, so here's the inside of a chapel, Here's like a desert. You can download these images. You can import them into Fusion. I think I did one earlier, so we'll take a look at it. All right, so this is a park. It's pretty kind of hard to see, so I'm going to mess with it a little bit. I'm going to go into settings and just up the brightness a little bit. And you'll notice that everything is super, super pixelated because it's trying to save your computer's processing power. So mess around with the settings all you like. Make the actual model look nice. Make the background look nice. And then this T-pop button up here is your final render, right? You're going to send this file to Fusion's headquarters. They're going to render it for you, and they're going to send you back a JPEG. It takes a lot of time. It takes a bit of currency, but the currency is free. So before you do that, you want to preview and make sure it looks right. So over here, there's only about 8 buttons on the top. You really don't need all of them. The only ones you need are appearance and scene settings for setup. And then to preview, you can use this button right here with the play button. So if you click on it, it's going to compile everything into its final finished form. So you can notice the background finally became like the full 4K image it is. So it's taking up a lot more processing power. The image, or the actual model itself, got a lot more defined. And on the bottom in this right-hand corner, it tells me how much it's rendered it. So I can keep going like infinitely to make it more and more rendered, get it into higher definition. And what you see here when you push render is what's going to be sent to Fusion. That's the JPEG that's going to come back to you. So within this preview mode, you can actually kind of pan around a little bit. So it's going to break up the image a little bit, and then it's going to re-render it for you. So you can kind of scroll around and try to see if you find an angle that you like. Again, it's going to re-render itself. I think this looks pretty nice. And then you can go and push the render button. And it should pop up with a little menu. Here you go. So you're going to want to do custom. Again, all of this is just basic photography terms. You want to do cloud render, final, and then I'll do it for you, render. And it's going to take up a credit, and it's going to send it out to Fusion to get it rendered. It might take a couple hours. It could take 10 minutes. It could take 3 to 4 hours. You can close your computer and go somewhere else. But when you come back, you're going to find your image right down here on this tab. And this is going to be your full, proper PNG or JPEG, fully rendered. It's going to be a really high quality definition picture. So that's what want you guys to turn in. And then again, if you ever want to showcase this to anybody, this is going to be a really good kind of like thumbnail or picture to show off. So that's the rendering aspect. It's a little vague and kind of quick, but you can kind of see how it's pretty separate from Fusion. It's all basically photography based. All you need to use for this final assignment is the things that I showed you, right? The appearance, how to add a background if you want one, how to do a preview render, and then how to do the final render. And like I said, the final render could take anywhere for hours. As soon as you push render and you see this little icon down here, right, you know Fusion's working on it, you can close your computer and you can come back in a couple hours or the next day, and it'll be sitting here waiting for you. So is there any questions on this aspect of Fusion and of the final project? Okay. So one last thing is going to be slicing, right? So in the email is a link to Ultimate Cura. I'm not too sure if any of you have gotten it downloaded. Can I just get a quick raise of hands of people who have gotten it downloaded? Okay, what about, put your hands down. Raise your hand if you haven't gotten it downloaded. Okay. So whenever you download Ultimate Cura, you're going to get a big screen at the beginning. It's going to ask you what printer you're using. You can select any printer. All it's going to do is it's just going to change the settings just a little bit to optimize the whole process for that specific printer. We use a Creality one, but it's not important because we're going to be the ones printing it. But we just want to show you the actual program itself. So if you get to that part while setting it up, you can call one of us over and help you out. It's not an important setting, basically telling you that you can ignore it and just choose something random. But again, if you get stuck, you're going to call one of us over. So to get a part in there, right, so we have Fusion open. We need to export our part. So under here, under File, is Export. So we're going to click Export. It's going to open up this little splash page. Down here is Location. So by default, it's Downloads, right? That's typically where I like most of my downloads to go. I'm going to keep it there. And then you need to change the file type. For the assignment, you actually need to submit the Fusion file raw. So right now, I would push export and turn this in, and that would be one of the credits. And the other one would be actually slicing it. So I need a different file format. To get a form or a file into your slicer, you need a .stl file. So you can scroll down. It's going to be one of the last ones. And this is the file extension that you use to import your file into your slicer. So I'm going to do it right now. I'm going to push export. Should pop up with a timeline bar. Could take a couple seconds, could take a couple minutes. All right. I'm not too sure how long it's going to take, so I'm just going to use a different file. But here's Ultimaker Cura, right? Totally separate software that we're going to be using to slice it. And once this opens up, I can show you what it looks like. Okay, so you notice this is what your home screen is going to look like, right? It's just a bed. This is the printer bed. Printers are defined to a certain area in which they can print. And so, for example, I have my program set up with our custom specs for our printer. Again, doesn't matter which one you use. So this is the size of our bed. To get it to slice, you're going to go to File, and then Open Files. You're going to go find your STL file of your project, and you're going to import it into here, right? So it's going to import, here's somebody else's project. It's going to import it here into Cura. You can then click on your part, and the menu on the left-hand side now suddenly opens up. So you now have the ability to move it across the bed, right? So let's say you want to be like space conscientious and you want to put it in the corner. You can do so. Let's say you actually made it too big and you want to scale it down. This is actually pretty reasonably sized. But let's say we wanted to make it a little bit smaller. We could change the dimensions and it shrinks it down. Let's say this actually isn't how we want to print it. We want to print it vertically. We can rotate it as such. So this allows us to tweak with the layout of the print before we print it. We have mirror here as well, and some other features as well. But whenever you're happy with what it looks like, right? So you typically just want to scale it down and move it to a proper location. You can push slice right here. And slice is going to compile it into something called G-code. G-code is the language that 3D printers use to run. It's a set of typically like Cartesian coordinates, so it tells the printer to go here for X amount of seconds, lay down X amount of filament, and then once you're done, move to location Y and repeat. And it's hundreds and hundreds and hundreds of steps to make your big file. So lay it out as you like. You can push slice, and then as I mentioned, what we want to see is preview. So preview is going to show us what it looks like, and this is how it's going to print. So this is actually not good because you'll notice that most of it is light blue. For this program, light blue is supports. So I mentioned this in the last class, right? You can't leave kind of empty space whenever you print, right? If you're going to print like a canopy and you want to print it standing up, everything underneath that roof can't just be left empty. It has to be filled. So in this case, if we choose to print the P vertically, it needs supports to hold up the top part of the P. That's why you'll notice the whole thing is nested in this blue shape, right? We can't let it just print just the P because it'll fall over. So we have to print the whole thing in a block so that it has the structural support to stand up. So this is honestly a pretty bad example of how to print. So I'm going to go back and change it. You'll notice that if we print it this other way, where it's laying down flat, and then we push slice, and then we go preview, it's going to be totally different appearance. So now you'll notice that the only light blue we see is around the perimeter, right? It doesn't require any supports because we have it on its most stable layout, right? So that's what we want to see you guys on the slice image. Just import it in, scale it down to the right size, try to find the most stable way to print it and orient it that way, and then send us a screenshot just like this of the slice. We want to see all the colors, right? The colors tell us the different patterns and how it's going to be printing. Is there any questions on this slicing component of the project? Okay. With that being said, I'm going to take a couple minutes to open up the attendance sheet and see if there's any topics that anybody wants covered. But with that, You guys are more than welcome to start working on your final projects. We have a lot of TAs here today, so if you have any questions, please call us over. This is going to be the best time to get a lot of work done, as you have a lot of resources available to come and help you guys. But that's all I have for you guys. And yeah, just let us know if you need anything.